Hi everybody, this is Mr. Rigger. I'm going to give a real quick video here for 10-5, which is area using trigonometry. So, let's say we have a regular pentagon, really any regular shape. We're going to have to remember that the area is 1/2 times the apothem times the perimeter. Now, when they give us problems in 10-5, they're going to expect us to use trigonometry. And they're going to give us one of 4 potential pieces of information about this pentagon. So number 1, they might give me a radius. That's from the center to a corner. That's the radius. Now, they might also give me, number 2, they might give me a side length. Number 3, related to the side length, they might give me the perimeter, which I have to remember is 5 times the side length in a pentagon. In a hexagon, it's going to be 6 times the side length because I have 6 sides. Think about the number of sides you have. Or for number 4, they might give me the apothem, which is actually very nice of them because we need the apothem in our equation. So this is the apothem. Those are the 4 pieces they might give me. So if we remember from 10-3, if I have a pentagon, and it's a regular pentagon, I have the apothem here, and I get this triangle right here. And that's what we're going to use our trig for. So let's do a little recap. I have a regular pentagon, and if I have the center, I can draw all these triangles. I have 1, 2, 3, 4, 5 triangles. 360 divided by 5 is 72. So this is 72 degrees, 72, 72, 72, 72, because when I add them all up, I get a whole 360, one way around the circle. So 72 gets split in half, and I get 36 right here, because this apothem is going to split that 72 right in half. So I have this triangle to work with in my pentagon. 36 degrees, 90, and then this here doesn't really matter. Now the question is, what are they going to give me? So let's say that they tell me that my side length is 4. So if side is 4, then, let's say it's 4 inches, then really, this whole side is going to be 4. And this apothem not only cuts the angle in half, we said, it also cuts the side in half. So this is going to be 2 over here, that's going to be 2 over here. I get a 2 right there. And I need to know what my apothem is. So I have to use some trig. This is 36 degrees, and for my 36, 2 is my opposite. This is my adjacent, and this is my hypotenuse. And if I'm thinking about SOHCAHTOA, which one do I need? I have apothem, which is the adjacent, and opposite. I need tangent, opposite, and adjacent. So I'm going to say that the tangent of 36 degrees is equal to the opposite side, which is 2, over the adjacent, which is my apothem. Now this is where we had trouble in the class in the past. We're going to say that the apothem is 2 over the tangent of 36 degrees. These two get to switch places. That's one of our special rules. Tangent and apothem get to switch places when your variable's on the bottom. Switch places. Now, I have to use my calculator, and I'm going to make sure that I'm in degree mode. So I'm going to grab my calculator real quick. I'm in degree mode. I'm going to put it right here, and I'm going to do the calculation 2 divided by the tangent of 36 degrees. I'm going to close that parenthesis and press enter, and that's going to be 2.75 inches. That's what my apothem is. So I have the apothem, and for my area, I need 1/2 times apothem times perimeter. So I have 1/2. I have 2.75, but I don't have the perimeter. I do know that the side, though, is 4 inches, which means my perimeter is 5 times those 4 inches, which is 20 inches long. So 20 inches. There's a lot of steps on these problems. So now I'm going to quickly do that in my calculator. I'm going to do 1/2 times 2.75 times my 20 inches, and I'm going to get 27.5. And my area for this shape is 27.5 inches squared.